A very warm welcome to all my dear students. In this video, we are going to learn about sound. So first of all, we should understand that what do we mean about sound. So sound is the form of energy that produces the sensation of hearing in our ears. Sound is produced in the form of vibrations. These vibrations, whenever are produced, they also result in the production of vibrations in our ears, and as a result of which a sensation of hearing is produced. Now we will learn about that what is the meaning of this vibration. Vibration means the to and fro movement of particles. The to and fro movement of particles about their mean position is known as vibration. These vibrations, when produced, whenever we speak, we are producing vibrations. So when these vibrations, by the help of a medium, reaches to our ears, it produces a sensation of hearing. Now we will understand that how does the sound travel into the medium. For the propagation of sound, the thing which is very important is the presence of medium. If there is no medium, the sound cannot travel from one person to another person or from the source towards the receiver. So that is why here comes a very important question, that why we are not able to hear one person to another person on the surface of moon, because there is no atmosphere over there. There is no medium which will carry the vibrations from one side to the other side or from the source to the receiver. So it is very necessary to have a medium. So where is the vibrations produced? If I am speaking, then the vibration is produced by the vocal cords, which are carried forward by the particles of the medium. The particles in the medium vibrate. The particles will vibrate. Okay, and as a result of which these vibrations are transferred from one person to another person in the form of the energy, and this energy is received by the ears and which produces a sensation of hearing. The sound propagates in a medium in the form of compression and rarefaction. If I will have a person here and a person here, this person, when he speaks, he produces the sound. So the sound is carried by the medium in the form of compression. The other particles are in rarefaction. Then in the next step, we can see that these particles are in rarefaction and the next set of particles are compressed. As a result of which the compressions move forward and the person, we can say that the person B is able to hear to the sound of person A. This is how the sound propagates in a medium. Now let us understand that what are the factors related to the sound. So there are three factors which are related to the sound. One is loudness, another is pitch, and the next is known as quality of sound. So first of all, I am going to understand the meaning of loudness. What is loudness? So loudness means that how high the volume is or how low the volume is known as a flat sound or a grave sound. Okay. Now here, the wave is produced in the form of a longitudinal wave. If I compare this wave and this wave, okay, in the wave A and in wave B, there is a difference in what? The displacement of particle from the mean position. Here we can see the displacement is A1, and if I am taking the displacement A2 here, we can see that A2 is greater than A1. A2 is greater than A1, which shows that the loudness of sound A2 is greater than the loudness of sound A1, because the amplitude of vibration is more. The amplitude of vibration is less in the first sound, so here the loudness will be smaller. So loudness depends upon the distance of the particle from the mean position, the distance of the vibrating particle from the mean position. This is known as amplitude. Okay. Now, how loudly or how small, in a lower loudness the sound will be audible to us, this depends upon three factors in loudness. The first factor in loudness is the distance between source and receiver. Distance between source and receiver. if the distance between the source and receiver is large, then the volume of sound heard will be less. If we are standing close to the sound source, then the loudness of the sound heard will be more. If you are standing at a distance from the sound source, then the loudness of the sound heard will be more. So it depends upon the distance. Less is the distance, louder sound will be heard. More is the distance, a feeble sound will be heard to us. The second factor is the area of vibrating membrane. The area of vibrating membrane. In this case, when we are talking about the area of vibrating membrane, we must understand that the area, if I'll consider that example, the area of the vibrating membrane of a tabla is smaller than the area of vibrating membrane of a drum. So we all know that in case of drum, a louder sound is heard, while in case of a tabla, a feeble sound is heard as compared to drum, I am saying. Okay, so in case of a drum, the vibrating area is more, but in case of the tabla, vibrating area is small. That is why the louder sound will be heard in case of the drum, because the area of vibrating surface is more, and in tabla the area of vibrating surface is small. Then after loudness, we have to understand about the pitch. Okay, so pitch means depends upon frequency. The pitch depends upon, is directly proportional to frequency of sound. Okay, now first of all, I should also make you understand that what is frequency. So frequency means the number of vibrations in 1 second. So if the number of vibrations in 1 second is more, it means that particular wave will have higher frequency. And if the number of vibrations is less, it means that particular wave will have a lower frequency. So let us understand here by the two waves. And wave B, I am drawing it like this. Okay, so it is clearly visible from the wave A and in wave B. The number of vibrations here is less, the frequency is less, and here the number of vibrations is more, the frequency is more. So here a low pitch sound will be heard. A low pitch sound will be heard. Here the sound will be flat or grave. Here the sound will be flat or grave. But in this case, a high pitch sound will be heard. It will be of high pitch. And here we will have a shrill sound. We will have a shrill sound. Okay. So a flat sound or a grave sound is normally heard in case of male, and a shrill sound is normally heard in case of females, women. Okay. So pitch is directly proportional to frequency of sound, and frequency means the number of vibrations in 1 second. The number of vibrations in case A is less, so here we are saying that it is a low pitch sound and it is flat or grave sound and is normally heard in case of the males. A high pitch sound is normally heard in case of women, and it is having a high pitch. A shrill sound is produced, and also it is considered in case of women. Okay, now I think up to this it would be understood to all of you. Now let us understand one experiment related to the propagation of sound, that in which we will see that the medium is the most necessary thing for the vibrations to propagate. We'll take a bell jar experiment. In this we'll take a jar. In this jar we are keeping a clock. Okay. In this jar we are keeping a clock or an alarm. Okay. Then this is connected with a battery. And here it is fixed with a stopper. Alright. So initially what do we see, that when we turn on this battery and the switch is closed, then the bell starts ringing. We can see through the jar that this hammer is striking the gong, and now the sound is heard. initially the sound is heard. When we see that this hammer is striking the gong, we can hear that the sound of the bell is there. Okay. Now after this, after hearing the sound of the bell, what we are doing next is we are taking our evacuation pump, and with the help of that evacuation pump we are taking all the air from inside. We are just taking all the air which is already present inside the jar outside, such that inside we are creating a vacuum inside of the bell jar. Now air is not present. Now we are creating a vacuum inside the bell jar. After creating a vacuum inside the bell jar, again we will press the switch and we can see through our eyes that the hammer is striking the gong, but the sound is not heard. In the second case, after evacuation of the air from here in this jar, when the vacuum is created, we can see through our eyes that the hammer is striking the gong, but no sound is heard, which shows us that air is very important, or a medium is very important for the propagation of sound. Now, the medium for the propagation of sound should also be having two characteristics. One is elasticity, and the next, it should be having inertia. Okay, so that is why, depending upon the elasticity of the medium and the inertia of the molecules of the medium, we have different speeds of sound in different mediums. Like the speed of sound in solid is highest, the speed of sound in liquid is less than solid, and the speed of sound in air or in gas is the least. Okay? Because the solid is having more inertia, it is more elastic as compared to liquid and gas. Liquid is having more inertia and more elasticity as compared to gases. So this is how what affects the speed of sound in the different media. Now let us understand about the different audible range. Okay, the audible range for the human beings, the different ranges of the sound. The audible range for the human beings is from 20 hertz. It's from 20 hertz to 20,000 hertz. Any sound which is produced in this range can be heard by a human being. This range is from 20 hertz to 20,000 hertz. This range is known as audible range. Then we have infrasonic sounds. Infrasonic sounds. Now let us understand what is an infrasonic sound. An infrasonic or subsonic sound is the sound which is of the frequency range less than 20 hertz. The sounds which are less than 20 hertz are known as the infrasonic sounds. It is of less than 20 hertz. This range of sound is not audible by human beings. This range of sound is audible by the animals like cats and dogs. Okay. Now let us understand about the next kind of sound, next range of sound, that is known as ultrasonic sounds. Ultrasonic sounds. The sounds which are of the frequency more than 20,000 hertz, are called as the ultrasonic sounds. These ultrasonic sounds are used by the bats to find out their prey or for the detection of the obstacles. The sounds, ultrasonic sound is very important. It is having a lot of properties because of which it finds its uses in the physics. The first one is because of one of its property because of which it finds its use in the physics is its high directivity, and that is why it is used by the bats to produce to detect their obstacles. It is also used for doing the ultrasounds in the patients, and it is also used as a cutting tool. Okay, so with this we understand about the different ranges of the sound which is dependent upon the frequency. So the sound which is audible to the human beings is from 20 hertz to 20,000 hertz. The infrasonic sound is less than 20 hertz, which is not audible to the human beings. Then we have ultrasonic sound, which is more than 20,000 hertz, and it is used by the bats to find out their prey. Now, what is the speed of sound in air? The speed of sound in air is air is 330 meter per second. Okay, and when we hear the sound, that sound remains or has effect on our ears for 1/10th of a second, which is known as persistence of hearing. Okay, so persistence of hearing for human beings is 1/10th of a second or 0.1 second. Now here, while I have discussed this persistence of hearing, to make you understand about the another term which is related to the sound, and that is echo. Echo means reflection of sound. Echo means reflection of sound. When we hear the reflected sound after a time interval of 0.1 second, then we are able to recognize the two sounds differently. So in that case, we are able to hear the echo separately. See, now when we are in a closed room or when we are surrounded by a lot of obstacles which are near to us, the reflected sound comes to us within a time period of 0.1 second. So that is why our mind is not able to differentiate between this original sound and the reflected sound. So echo is not heard. But when we are in a hilly region where the obstacles are at very far place and the reflected sound comes after an interval of 0.1 second, then we are able to recognize the difference between our sound and the reflected sound. So there comes the word which is known as echo, the reflection of sound. So for this, it is very necessary that the distance between the source and the receiver is large, so that the reflected sound comes to the person after 0.1 seconds. So I hope that all the topics that we have discussed in this chapter is understood to all of you. So we'll conclude the class here. Thank you everyone.